In this video, we are also going to be discussing two topics. We're going to be talking about coterminal angles and reference angles since they go together. So a coterminal angle, it's basically what it means is in its name. Co meaning that they share, terminal, well, terminal side. So they share a terminal side. So there are many angles. So you saw that we could sketch an angle going around the circle multiple times. And if it falls on the exact same line, they are considered to be coterminal angles. So the nice thing about coterminal angles is since they are on the exact same line, that means that you only need to think about things that are 360 degrees away from that, because 360 degrees gives you a full circle. So if we are trying to find coterminal angles, all we need to do is add or subtract 360 degrees, or add and subtract 2 pi, since both of these represent full circles. So let's look at some examples. So here we want to try to find two coterminal angles for this angle. We're going to try to find a positive and we're going to try to find a negative version. So, well, to find a positive, all I would need to do is take 50 degrees and add 360 degrees, because that would be me going in a full circle away from that 50, and I would land right back at the same place. So that means the angle of 410 also terminates at the same place that 50 degrees does. We can also go the other way. So I can take 50 degrees and subtract 360 degrees. So that means I'm going the opposite direction of rotation, but I'm going to land at the same location as that 50 degrees, and I get out a negative 310 degrees. So these are both coterminal angles that share the same side, so the same terminate side as the 50 degrees. So looking at this next problem, again I want to find a positive and a negative, but since this one's so far negative, I'm going to take the negative 780 degrees and start by adding 360 to it. So doing that, I get negative 420. So that could be my negative. They both are going to share the exact same location. But since I'm trying to find a positive, I need to then go and take that negative 420 and add 360 again to it to try to get it closer to its positive side. And again, I fall short. I'm at negative 60. So I can do it one more time though. I can take that negative 60 and I can add 360 again. And this time I get out 300 degrees. So that means that I could use these two as my answer, or I could use the 300 and the negative 420 as my answer for the positive and negative. It doesn't matter. I just needed one positive and one negative. So sometimes when you're trying to find coterminal sides that, coterminal angles that fall on the same side, you need to add 360 multiple times, or you may need to subtract 360 multiple times in order to get there. So let's talk about radians. So with radians, we need to, basically work with fractions. It's going to be the exact same thing, where I just need to add 2 pi or subtract 2 pi from these numbers in order to get the location. So this is a pi over 2, and I'm going to add 2 pi to this in order to get out my positive coterminal angle. Now, I need to go and find a common denominator, which would be 2. So that would make my second term 4 pi over 2. So I just multiplied by 2 over 2. And now since they have the common denominator, I can add them together. 1 pi plus 4 pi gives me 5 pi over 2. So what you're basically doing here is you are kind of treating pi like it's a variable. So it's not a variable, it's a known number, but we treat it like it's a variable when we're adding and subtracting or multiplying, so forth and so on. So that means that I'm not actually going to go and use pi. I'm going to just keep it outside the entire time. So I'm just going to do the math with the coefficients and treat pi like it's x. So I also need to find a negative version. So that means I would need to take pi over 2 and subtract 2 pi. So again, I would convert this and I would get pi over 2 minus 4 pi over 2. And you can kind of see all I'm doing is I'm taking whatever this denominator is and I'm multiplying it to the numerator and the denominator, and then I can just add them together since I'm just adding 2 pi, and that will work 100% of the time. So this gives me a negative 3 pi over 2 as my negative. So if you're not comfortable with fractions, you can always convert to degrees and then add, subtract 360, but then you must convert it back to radians. So that's the thing. If the problem starts in radians, you need to finish it in radians. So that means you would have to convert twice. Once to degrees, then once back to radians, and you're adding 360 and subtracting 360. So it's up to you. You could get better at fractions or not get better at fractions. So I'm going to keep working with these fractions. So we have negative 12 pi over 5, so we have negative 12 pi over 5. I'm going to start by adding 2 pi to this. So me converting this 2 pi is just me multiplying 2 pi by 5 over 5, which gives me 10 pi over 5. So adding my numerators together, that gives me negative 2 pi, and my denominator stays the same. So again, I got a negative answer when I added it, so that means I need to add it again in order to get to the positive answer. So I'm going to take negative 2 pi over 5, and I'm going to add, well, I already changed it to 10 pi over 5, so I'm just going to keep 10 pi over 5. And I get out 8 pi over 5. So, in my opinion, adding fractions is quicker than having to convert to degrees, than adding 360, subtracting 360, then converting back. Because again, all I'm doing is I'm taking whatever the denominator is and I'm multiplying it to the 2 pi and just also keeping it as the denominator. So I now have my 2, positive and negative. So here are 2 for you to try. So on the first one, 2 that I got were 135 degrees and negative 225 degrees. So those are both acceptable. You could have added 360 to that 495 and gotten a different answer. You could have kept adding 360 degrees and gotten some ridiculous number. So like for instance, you could have said your positive answer was 5,895 degrees. That is also a coterminal angle for 495 degrees, so that is fine. Same with the radians. As you can see, there are a bunch of different options. Since you had to add the negative or add a 2 pi multiple times, so there are multiple different answers you could have put for your negative and all would have been fine. as long as they're right. So let's go on and talk about reference angles. So what a reference angle is, it is referring to an angle, and it's always referring to an angle that is less than 90 degrees, and that angle will always be formed between an x-axis and the angle. So always, always, always. So these are your 4 options. So there's only 4 different ways you can find a reference angle. And if your angle is in the first quadrant, then the reference angle is just going to be the angle to the nearest to this x-axis over here. If you're in the second, the reference angle is going to be the angle that's formed between the negative x-axis and this angle. If you're in quadrant 3, it uses the negative x-axis again to help you try to find that angle. And again, they're always going to be less than 90 degrees, and it's always, always, always with the x-axis. X-axis, x-axis all the time. Do not do the y-axis. That is one of the number 1 mistakes. So it is always with the nearest x-axis. So some examples. So what I would recommend you do is to actually sketch out the angle. That way you can try to find out where the nearest x-axis is. So I'm going to come over here and I'm going to quickly sketch out 300 degrees. So here's 300 degrees. So my reference angle is the angle that's formed here. Zoom in. So it's this red angle that I'm looking for. Well, if you think about it, if I used the blue and I kept going with the red, that gives me a total of 360 degrees. So if I wanted to just find the red piece, all I have to do is take the 360 degrees, subtract the 300 degrees that we did go, and that gives me my reference angle of 60 degrees. So that means that this red piece is 60 degrees. So that's what's left over. So I used the fact that if I continued this spiral and I hit that nearest x-axis, that would have given me a total of 360 degrees. So then I took that 360 degrees, I subtracted it from what angle I was given, and that found me what was left over in order to get me to that 360. So let's look at another example. So 135. So again, I can go and I can sketch a negative 135. So since it's negative, so that's telling me I need to go down. So here is a negative 135. So again, I need to find the nearest x-axis, which would be over here. So if you see, the blue and the red make 180. So the blue plus the red equal 180. So that means that if I subtract the blue from this green, so if I take 180 and I subtract the blue, which is 135, so note that this negative right here is not this negative. Those are not the exact same negative. So this negative is basically saying that I'm taking it away from what would be 180 degrees. You could say that this was a negative 180, and then you would be basically subtracting the negative. Just don't. Treat it like it's an absolute value angles when you're thinking about it. So I'm subtracting that 1 35, so that means that the red that is left over is 45 degrees. So notice that it's a positive value because it has to be between 0 and 90 degrees. So this must always be positive. So reference angles are always positive because it needs to be between 0 and 90 degrees. So that's why I'm treating the angles like they are absolute values, and I'm basically just doing the math where I just subtracted the blue piece on both sides. So let's do the same thing with our radians. So again, I want to go and sketch my radians. So negative 7 pi over 10 is going to land me over here. So again, I'm looking for this red piece. So if I think about it, the blue plus the red should give me 180 degrees, but 180 degrees is equal to pi, and since we're talking about radians, this is going to equal pi. So again, I can do the same thing where I'm going to take that 7 pi over 10 and subtract it on both sides. So I have pi minus 7 pi over 10 is going to give me my answer. So again, I need the common denominator, so this is just 10 pi over 10 minus 7 pi over 10, so that equals 3 pi over 10. So that reference angle is 3 pi over 10. So again, I'm just trying to find out the angle that it keeps making. So let's try one more. Let's do 7 pi over 6. So sketching out 7 pi over 6 is going to land me here in the third quadrant. I guess let me do the blues. But the nearest x-axis is this one over here. So what I need to do is, this is going to be a little bit different, because if I think about it, the blue angle minus the red angle would give me out 180 degrees, or it would give me out pi. So because I'm basically canceling out this leftover piece of the blue one, and all I would be left with would be this 180 degrees or this pi radian left over. So that's why I'm subtracting it instead. So since I'm trying to solve for the red piece, that means that when I do this subtraction, so if you think about it, you would be subtracting the blue piece on both sides, and you would be left out with a negative red equals the pi minus the blue. And I would just need to get rid of the sign, so just multiply everything by that negative. So the end result is just going to be the negative pi plus the blue piece. So I know that that's kind of like a complicated way of thinking about it, but really all that you're going to do is you're going to still take pi minus the 7 pi over 6, and whatever you get out, you just make it positive. So that's basically what this piece is kind of saying, is just you're still doing the subtraction, but whatever you get out, just make it positive. So we can add these or subtract these things. So I need a common denominator. So this would be 6 pi over 6 minus 7 pi over 6. And 6 minus 7 gives me negative 1 pi over 6. And this is what I'm saying about make it a positive. So your final answer is just pi over 6. So reference angles must always be positive, and they must always be between 0 and 160, or in the radians case, it would be between 0 and pi over 2. And pi over 6 is between those two values. So here are 2 U-tries for you to try. Find those reference angles. All right, on the first one, you should have gotten 45 degrees, and on the second one, you should have gotten pi over 4.